Okay, so we're going to be looking at some more equations involving complex numbers. Particularly, we're going to look at complex equations that require the use of De Moivre's theorem. Now, you remember that De Moivre's theorem here is that when we raise a complex number to a power n, we raise our modulus to the power of n, and we multiply the argument by n. So in this particular example, we've got this equation, z to the power of 4 equals 1. Now previously, you would have thought, what to the power of 4 equals 1? Well, it's 1. But that's just one solution. Okay, and we're going to work out all the solutions. Remember, a complex polynomial has to a degree of n will have n complex solutions, and so we would expect there to be 4 solutions because this equation has a degree of 4, so we expect 4 solutions. 1 is just one of them, which we intuitively know. Okay, so let's look at it. So we're going to just represent our complex number z in what, remember, is polar coordinate form. Now this isn't essential to represent it in this form, but I find it a helpful way and a nice brief sort of way of representing it. Okay, so we've got our modulus r and our argument theta. Now, if z is represented by r theta, then z to the power of 4 by De Moivre's theorem will be r to the power of 4 and 4 theta. So our modulus is r to the 4 and our argument is now 4 times theta. We now need to express the right hand side of this equation, okay, this equation here, as 1 equals 1 to n pi. Now, where am I getting this from? Okay, so we've got this, remember, is still a complex number. Okay, the number 1. Let's think about where it is represented on the Argand plane, and that might help in working it out. Okay, so you remember that this is our imaginary axis, this is our real axis, and the number 1 is going to sit here, okay, on our real axis, okay, because there's no imaginary part. So that's our modulus 1, but our argument theta can be found as we go round as many times as we like. Okay, so we know what's the basic angle here is going to be 0. Well, if we go around once, then it's going to be 2 pi. Okay, in terms of radians, 2 pi or 360 degrees. So if n is 1, okay, then it's going to be once around and the angle will be 2 pi. If n is 2, then we go around twice, okay, and it's 2 times 2 pi or 4 pi. Okay, so just thinking back to our understanding of the unit circle and how our angles work in that. Okay, so our modulus is 1 and our angle is 2n pi, n just being a whole number value, which corresponds to our power here. Okay, now, and so that's that. But let's have a look here, and this sort of highlights it. Okay, 1 can be written as cis 2n pi. That's another way of writing it. 1 times cis 2n pi. Okay, so we have to consider the position of the number 1 on the Argand plane, and that just helps us to understand why our argument is 2n pi. Okay, let's move down and see what we've got. So we know our complex number z is represented by 4r to the 4, so z to the 4, this is our left hand side, okay, z to the power of 4, and that's our r to the 4 for theta. Now z to the power of 4 is equal to 1. So this is our left hand side and this is our right hand side. So r to the 4 for theta is equal to 1 to n pi. So now let's look at these parts separately. So r to the 4 corresponds to 1, and so that's written here. R to the 4 equals 1. Our angle, the argument for theta, is equal to 2n pi. And then, because we're just looking now at our modulus, then solving for r is just going to be 1. Okay, so we just remember the modulus is just a real number value, so we're just looking at it being 1. Okay, and remember that the modulus is actually the distance from 0. Okay, so that's that distance here, from the origin to the point on the Argand plane. That's the definition of our modulus. So r is equal to 1. The angle theta, okay, is going to be given by, once we divide by 4, okay, n pi over 2. So 2n pi divided by 4, simplifying to n pi over 2. Now, what we're going to look at then is our solution to z as we work through different values of n. Now, since the degree of the polynomial is 4, there will be 4 complex solutions, and so we need to consider the values of n 4 times. And we're just going to start, it's quite simple to start with a value of 0. Okay, n equals 0, 1, 2 and 3, so that will give us our 4 solutions. So if n equals 0, our first solution for z will be given by 1, 0, because our modulus is going to be the same every time. It's going to be 1, but our angle is what changes. Okay, so n being 0, obviously theta becomes 0 because of 0 times pi over 2 gives us 0. And so expanding that out, because remember this is our polar coordinate form, and that's going to be equal to r cis theta. So our r value is 1 and our angle is, in this case, 0. And then we work out our values for cos and sine. Cos of 0 we know is 1 and sine of 0 is 0. So 0 times I is 0. So we're left with just cos of 0, which is 1. So substituting n equals 0 gives us our first solution for z of being 1. Okay, we'll take on the next value of n equals 1. When n equals 1, we've got 1 times pi over 2, which is pi over 2. And so we substitute into our cis equation. Okay, so it's 1 times cos of pi over 2 plus I sine pi over 2. Now cos of pi over 2 is 0 this time, whereas sine of pi over 2 is 1. So we've just got 1 times I, which is I. So I is our second solution. And now we substitute our value for n equals 2. So 2n pi over 2 is pi. And we have cos of pi plus I sine of pi. Cos of pi is negative 1. Sine of pi is 0, so we have our solution of negative 1. And then our fourth is obtained by using n equal to 3. So it's 3 pi over 2. Cos of 3 pi over 2 is 0. Sine of 3 pi over 2 is negative 1. So our fourth solution is negative I. And so we find that the 4 solutions we've got for z to the power of 4 equals 1 are plus or minus 1 and plus or minus I. Okay, so I'd encourage you to go back through this example and just have a look at each step that needs doing. Okay, so we're just remembering the importance of whatever the degree of the polynomial is, that's how many solutions there will be, and therefore you're going to need to substitute that number of values of n. And it's just quite simple. to start with n equals 0. Some people start with negative values and finish with positive values, but for my part I just like to just go with starting with 0 and working through, and we'll see how we can make things a little easier as we go. Okay? Alright. The next videos we'll go through a few more examples.